We are going to be covering converting units or dimensional analysis in this section. So we're going to look here at some of the things that you're going to have to remember. Goal 1, we went through and talked about prefixes, so we're going to go back and talk a little bit about some of those here in a minute. So what we have to remember is sometimes there's going to be units that are more convenient to use, and so we're going to have to convert from one unit to another, and that's what is called dimensional analysis. Sometimes it's just abbreviated DA. Probably in junior high you learned how to do just moving the decimal place. That's not going to be okay now because in chemistry we are going to be converting a lot, and sometimes we have to convert more than one unit, and so what I want you guys to do is learn how to set these up correctly so that that will be easy when we continue to do that. So dimensional analysis is always going to use what's called equivalence or conversion factors. So here's one easy example. You all know that with every 1 foot there's 12 inches. Okay, so that's an easy conversion factor. One goes on top, one goes on bottom. So whenever you have two things equal to each other, one will go on top, one will go on bottom, and it can go either way. So it can be the foot on top of the inches or the inches on top of the foot. It really doesn't matter. It can be written both ways. Okay. So in the end, what happens is one thing is equal to the other, and so you end up with 1. Okay, they equal each other, so they're equal to 1. So that's what dimensional analysis is based on, that the idea that you can multiply anything by 1 as many times as you want, and you won't change the meaning of that measurement. Okay, so 27 inches times 1 we know is 27 inches. That doesn't change that. So dimensional analysis is based on that idea that if you want to multiply by 1, then you won't change the physical meaning of the measurement. So for this case here, if we have 27 inches and we want to know how many feet that is, okay, we're going to take our 1 foot that we know is equal to 12 inches and use that as our conversion factor. So this is just like a fraction. You would take your 27 inches times your 1 at the top, and you get the same number. You get 27. Then this is the bottom of our fraction, so then we would have to take our 12 inches and divide by 12. We have a factor on the top and on the bottom that will cancel out, and that is the label. If you have inches on the top of the fraction, inches on the bottom of the fraction. This is just like writing this over 1. Okay, so these will cancel each other out. 27 times 1 is 27. 27 divided by 12 gives us 2.25 feet. Now, we also have to look at significant figures. This is a conversion factor. It does not count in significant figures. 27 is the number that we need to look at. There's 2 significant figures here, so when we're done with our problem, we need to take our answer and convert it. Oops, this would be a 3, I apologize. Convert it to correct significant figures, I'm sorry. So here the 2 would have to round up to a 3, and then we would have feet for our label. Okay, so that's one example of a dimensional analysis problem. Okay, so this walks you through the same thing. The inches are going to cancel out. You end up with your answer. Again, make sure though you make this in correct significant figure. Our book is not very good about remembering to do that all the time, so that would then convert to 2.3 to have correct significant figures. Okay, so anything that's on the top and the bottom will cancel out just like any other fraction. Okay, so we cancel the units. Numbers can cancel too. So if we started with 12 inches, the 12s would cancel and we'd have 1 times 1 divided by 1, and we'd have 1 foot. Okay, so hopefully that's kind of common sense there, that would all work out. So here's our steps that we're going to follow. You're going to write down your given information, so what you're given in the problem. You're going to write down your answer blank and then the unit on the right side, and then you use your equivalence to cancel. You get your unit, and then you calculate your answer. You multiply across the top, and you divide through the bottom. These are just common equivalents. Most of the time we're not going to convert from English to metric. We're just going to do metric to metric. Okay, but these are a few you might need to refer to at some point in time here. Okay, so we write down our given information here. So in the example, how many grams are equal to 1.25 pounds? We write that down. That was step 1, sorry, I skipped a step. Step 2, you write down your answer blank with whatever label you want to end up with. We want to get to grams, so that's what we're going to write by that blank. Then we write our equivalents or our conversion factor. So if you go back to the conversion factors, we have 1 pound to 454 grams. So here, this label has to match this label because we want to end up with this for our final answer right here. Okay, so these are going to cancel out. We take 1.25 times 454 and we divide it by 1. Okay, when we do that, we end up with 568. We have 3 significant figures here, so we want 3 in our answer. Again, this is a conversion factor. It's just counted numbers, so those do not apply to a conversion factor or to significant figures. Okay. Metric prefixes, this is the review I told you about. Okay, I did not give you micro, but that's one that is -6. Okay, mega was +6. This one's -6th power. Okay, so those you can look through again and review those, and we're going to use these to be able to do some conversions here. Okay, so sometimes it's confusing. Do I multiply by 1,000? Do I divide by 1,000? How do I get from kilograms to grams? It's hard to remember that sometimes. Well, we know kilo equals 1,000, so there's got to be 1,000 grams in a kilogram, or 1,000 grams. Okay, so this can be written this way. This is not correct. Another way to look at it is the bigger unit is a kilogram. Your 1 always goes with that, and then kilo means 1,000, so you have 1,000 of that base unit. Okay, so that's how you would do that one. Milli is 1/1000th. Okay, there's a couple different ways you can write this. Liter is 1/1000th of a milliliter, or 1,000th of a liter equals 1 milliliter. Centi, 1 centimeter equals 100th of a meter, or 100th of a centimeter equals a meter. Another way to look at this is 1 liter equals 1,000 milliliters. Okay, or 1 meter equals 100 centimeters. I think this way is simpler because, again, you're going to look at the unit that's bigger and your 1 goes with that, so 1 liter, and then you know milli means 1,000th, so you have to have 1,000 of those to make up 1 of this. Centi means 1/100th, so you have to have 100 centimeters to make up your meter. The meter is the larger unit. Okay, so I like to think of it that way, and this takes you through that. Okay, so to find the volume of a cube, we've talked about this too, length times width times height. Okay, you get your volume. We know that that would be centimeters cubed. Okay. The other way we can write this is 1 centimeter cubed is equal to 1 milliliter. And this is just something that you have to remember. If you've ever done anything with medicine, a cc is a cubed centimeter. It's the same as a milliliter. So you just have to remember that that conversion factor is the same thing. So here's another example real quick. How many grams are equal to 127 milligrams? So which one's bigger? The gram. So we write 1 gram. Maybe we'll write 1 gram. 1 gram is equal to 1,000 milligrams. Okay, we look here. We're going to write our fraction. We know our 1,000 milligrams has to go on the bottom because we want that one to cancel out. And our 1 gram goes on top. Okay. If you like it better this way, you could put 1 milligram on the bottom and the 1,000th of a gram on top. We take our multiplication across the top and we divide by what's on the bottom. We cancel out our units, and in this case we would have 0.127. Significant figures, there's 4 here, so we need to add a 0 at the end here, so we have 4 significant figures there. So that's an example of how you would do an example of converting from grams to milligrams, milligrams to grams.